Hi, in this video we are going to learn about polynomial. Polynomials is one of the very important chapters of grade 9 as well as grade 10. It also forms the starting link between algebra and geometry. We'll see that in the later part of the video. Let's begin. At the very first outset, let me set the agenda how I will be going further in this demo video. First we'll learn the definition of the polynomials, the meaning. Then we'll also understand how to identify a polynomial. Then we'll have the different classifications of polynomial, and finally we'll be having the understanding of zeros of a polynomial along with their geometrical interpretation. So let's understand about the polynomials. To have an idea about polynomials, we must have a clear understanding of algebraic expressions. In our previous grades, we have understood what are algebraic expressions. Furthermore, in mathematics we have so many expressions, but we'll confine and restrict our scope of discussion to algebraic expression only. So we have seen any expression in mathematics of the form, here a is a constant term and x is a variable and n is also a real constant. So if we find anything which is written in this format, this picture shows the nature of algebraic term. For example, if we have 2 into x raised to some power, say 5, and this is a algebraic term. Furthermore, we can have a as any real value or number, any real number, and n is also any real number. Suppose I write pi is also a real number, of course irrational, and I take variable this time as t is some other variable, and raised to some power, say e. E is also a real number, pi is also a real number, so this is also an algebraic term. Further, we can also write like 1 by 3 y raised to root 2. This is also a algebraic term. Algebraic term. Summing up, so any expression which is of the form a constant multiplied with some variable and the variable is having a real power is a algebraic expression. So this is algebraic expression. Then what is polynomial expression, or what is the term of polynomial? There is very slight difference between polynomial and algebraic expression. Just see here. Here in algebraic expression, whatever the exponents or the powers which we take for the variable is any real number. But for the case of polynomials, the power of the variable is not any real number, rather the simpler numbers like which we can choose from 0, 1, 2, 3, 4, so on and so forth. So basically the powers of the variable in a term if is coming from this set, then we say the algebraic expression is a special expression and its name as polynomial. Therefore the powers in the polynomial are non-negative integral. Therefore we also say polynomials as non-negative integral power of variable x. After having understanding of algebraic expression along with the polynomial in comparison, now we are gonna define a polynomial. So the three things which we need to keep in our mind while defining a polynomial are: first thing is the nature of expression must be an algebraic expression. Algebraic expression, which means the different constituent terms in the expression must be of nature algebraic. Second thing, there should be a finite number of terms. A finite number of terms, which means a polynomial expression cannot have infinite number of terms. The third thing, which is very important, and gives a deciding factor to choose between an algebraic expression and a polynomial is the index n. Algebraic expression, the picture or the photo is a constant, a variable multiplied to it, whose power should be a real number, and for a polynomial this power, this exponent should be from these simpler numbers from the whole numbers, so on and so forth. So the exponent should be non-negative integer. So what are the three things? The nature of expression should be algebraic. There should be a finite number of terms in a polynomial expression, and for expression to be a polynomial, the power should be non-negative integer. Now moving to the next part, that is how we can identify a given expression whether it is a polynomial or not. Suppose we are given these many expressions, so we will list and find which polynomials are, which of these are polynomials and which of these are not polynomials. So let us begin with the first thing. We have expression 1 plus x square. So we need to check for every constituent terms. First term is 1. 1. Do we have 1 written in the format as ax raised to n, and n should be non-negative integer? Yes, we can write 1 as 1. 1 is one constant multiplied with some variable, say x, and whose power is another constant. I can write 1 as this. So this is in this format. So 1 is a polynomial term. Similarly, I can write for x. X is again 1 constant, x raised to 1. Yes. And so as for x square, 1 into x raised to 2. So since all the constituent terms are aligning with the format of polynomial term, so the whole expression is also a polynomial. Now moving to the second example. Here we have 1, which is a polynomial term. We have just seen x. This is also a polynomial term, x square, and so as x cube. So each of the constituent terms are the polynomial terms, and like that the further terms will also be individually polynomial terms. But as a whole, this expression will not be a polynomial. Why? Because it has infinite number of terms. These 3 dots signifies that this series is infinite series. It's not a finite series. It is unending series, and the number of terms are not finite here. Since the number of terms are not finite, this series or this expression becomes a not polynomial. Coming to the next example, here we have 1 is short of polynomial. We have just seen 1 by x. How can we write 1 by x? Let us see. 1 by x is written as 1 into x raised to minus 1. Yes. So 1 is a constant. Yes. X is a variable. Yes, it is a variable. But the power here, you see, power is minus 1. And what we wanted? We wanted power to be non-negative integer. Is minus 1 non-negative? No, it's short and negative. So this term, particularly this term, is not a polynomial term. Let us check for this term. However, if this single term is not polynomial, then the whole expression is turning out to be not a polynomial. But let us also check for this term. This is 1 by minus x square. So this is essentially x raised to minus 2, which is 1 into x raised to, minus of minus 2. So this is x raised to 2. So this term is also a polynomial term. But since we have one term which is not a polynomial, the whole expression turns out to be not polynomial. Let us see for this. Here pi is a constant multiplied to another constant e, and whose power is x. Is it matching with the format a x raised to n? This is constant, this is also constant. Do we have a variable multiplied over here with a constant? No, we do not have. We have a constant multiplied to a constant. This picture does not match. Therefore, this expression is not a polynomial term. This is a special term which we refer as exponential term. This is not a polynomial term, but it is an exponential term which we will discuss in the later lectures. Now discuss about this. This is e is some constant, and x is some variable raised to some constant. So what is this? Is this matching? Yeah, it is pretty much matching with the format a x raised to n. A is constant here, e is constant here, x is variable, and the power is constant real number. But the thing is, this pi is not coming from the non-negative integers, which should be 0, 1, 2, 3 in this format. Rather, pi is an irrational number which lies somewhere between 3.14 ... Since this is not a integer, therefore this expression is not a polynomial, rather it's just simply an algebraic term. So now moving to the third part, which is learning about the classification of polynomials. So we see polynomials can be classified on different bases. First basis forms when we think of the number of terms. Polynomials have so many terms. By just thinking how many terms a polynomial has, the polynomial can be classified. Just like we have several examples here. Considering this as a polynomial, it has 1, 2, 3 terms. So this is 3 means tri. This is the trinomial. And this is nothing but pi x raised to 0. So this is also a polynomial which is known as constant polynomial. Since the number of term is just one term we have in this, so it is mono. Mono means one. This is monomial. And here we have 1 and 2 terms, 1 term and 2 terms. So this is 2 means binomial. This is binomial, and it has many terms, 1, 2, 3, 4, 5. So this is as a whole polynomial. All these are polynomials since the very common names are just to represent how many number of terms. So this is trinomial, monomial, binomial, and in general all these are polynomials. Second basis is on the degree. What is degree of a polynomial? We have seen polynomial has so many terms. It can have so many terms. We check for every term, and the total power of variable in each term is checked. Whichever power is highest, that power is known as the degree of that polynomial. Just suppose this polynomial. Here the variable is x and power of variable is 0. So here the 0 is the degree for this term, and for this term the degree is 1, and for this term the degree is 2. So for polynomial as a whole, the degree is highest, which is 2. So as a whole polynomial, the degree here is 2. So this is known as second degree polynomial. Second degree polynomial, or we say quadratic polynomial. Here the degree of x or variable is 0. Since the degree of x is 0, it is a constant polynomial, we say. And in the third example, we have x raised to 0 in this term and x raised to 1 in this term. So whichever is the highest, clearly x raised to 1 power is the highest. So here this is first degree polynomial or degree 1 polynomial, which is also known as linear polynomial. And in this term, the power of variable is 3. In this term, the power is, for x variable the power is 2, and for y variable the power is 2. 2 plus 2, 4. And for this term, 1 plus 1, 2. For this, 0 plus 1, 1. And for this, 0 plus 0, 0. So we have seen the different powers. You can write 3 plus 0. For y, you can take the power as 0. So 3 plus 0, 3. 2 plus 2, 4. And 1 plus 1, 2. And 0 plus 1, 1.